Download this code from codegive.com, link in the description below. OK, let's break down A-level computer science OCR h446 slr10/1/3, specifically focusing on transaction processing with code examples. This area can be tricky, but with a thorough understanding, you can master it. 1. Understanding transaction processing. At its heart, transaction processing deals with sequences of operations, transactions, that need to be treated as a single, indivisible unit. Think of it like this: you can't have part of a transaction successful and part failing. It's all or nothing. What is a transaction? A logical unit of work. Examples: transferring money from one bank account to another. Ordering items from an online store. Booking a flight and hotel together. Why is it important? Crucial for data integrity, consistency, and reliability in database systems and any system where data must be accurate and up to date. Imagine the chaos if a bank debited one account but didn't credit the other during a transfer. 2. Key concepts and the ACID properties. Transaction processing is built upon the ACID properties. Understanding these is essential for the exam. Atomicity, the all or nothing principle. The entire transaction is treated as a single unit of work. If any part of the transaction fails, the entire transaction is rolled back, cancelled, and the system returns to its previous state. Consistency, the transaction maintains the integrity of the data. It moves the database from one valid state to another. Constraints, rules, and triggers are in place to ensure data remains valid. Isolation, transactions are isolated from each other. Concurrent transactions should not interfere with each other. Each transaction should behave as if it's the only transaction running on the system. Durability, once a transaction is committed, successfully completed, the changes are permanent and will survive even system failures, example power outages, crashes. Changes are typically written to stable storage, example disk, before a transaction is considered committed. 3. Transaction management techniques. Concurrency control, managing multiple transactions that are executing simultaneously to prevent data corruption and ensure isolation. Locking, a fundamental technique for concurrency control. It prevents multiple transactions from accessing the same data concurrently in a way that could lead to errors. Shared locks, read locks. Multiple transactions can hold a shared lock on the same data item simultaneously for reading. Exclusive locks, write locks. Only one transaction can hold an exclusive lock on a data item. This prevents other transactions from reading or writing the data while it's being modified. Deadlock, a situation where two or more transactions are blocked indefinitely, waiting for each other to release the locks that they need. Two-phase locking, 2PL, a concurrency control protocol that guarantees serializability. The transactions behave as if they were executed one after another. Growing phase, a transaction acquires locks but cannot release any locks. Shrinking phase, a transaction releases locks but cannot acquire any new locks. Timestamp ordering, transactions are assigned timestamps, and their execution is ordered based on these timestamps. Conflicts are resolved by comparing timestamps. Optimistic concurrency control, assumes that conflicts are rare. Transactions proceed without locking. Before committing, the system checks for conflicts. If conflicts are found, the transaction is rolled back. Rollback, abort, undoing the changes made by a transaction that has failed or needs to be cancelled. Asterisk commit asterisk making the changes made by a transaction permanent. 4. Database journals/logs. Database journals, or logs, are crucial for implementing atomicity and durability. Asterisk purpose asterisk to record all changes made to the database. Asterisk what they contain asterisk. Asterisk transaction ID. Asterisk operation type, example insert, update, delete. Asterisk data before the change, before image. Asterisk data after the change, after image. Asterisk how they are used asterisk. Asterisk rollback asterisk if a transaction fails, the log is used to undo the changes by applying the before images. Asterisk recovery asterisk if the system crashes, the log is used to redo or undo transactions to bring the database to a consistent state. Transactions that committed before the crash are redone, thereafter images are applied. Transactions that were in progress or aborted are undone, there before images are applied. 5. Example scenario, bank account transfer. Let's illustrate with a bank account transfer. Suppose we have two accounts, A and B, and we want to transfer $100 from A to B. The transaction asterisk. 1 debit $100 from account A. 2 credit $100 to account B. Pseudocode asterisk. The journal, log, entries, simplified. Let's say account A's initial balance is $500 and account B's is $1,000. Transaction ID operation account before image, balance, after image, balance. --. Transfer money update A 500 400. Transfer money update B 1000 1100. Transfer money commit. If the system crashes after updating account A but before updating account B asterisk asterisk. Asterisk the recovery process would see the transaction transfer money in the log. Asterisk it would check if the transaction was committed. Asterisk since it was not committed at the time of the crash, the recovery process would apply the before image for account A, restoring its balance to $500, effectively rolling back the debit from account A. If the system crashes after updating both account A and account B, but before writing the commit record to the log asterisk asterisk. Asterisk some recovery strategies might consider this an incomplete transaction and roll it back. However, a more sophisticated system might be able to check that the changes were actually written to the database and proceed to write the commit record. This demonstrates the complexities involved. 6. Python code example, illustrative and simplified. This is a very simplified example, not intended for production use. It shows the basic idea of transaction management in Python using a dictionary as a simplified database. For real database interaction, use a proper database library, example slide3, Psycha page 2 for PostgreSQL, PyMySQL for MySQL. Explanation of the Python code asterisk. Asterisk accounts dictionary asterisk this represents our database. It holds the account balances. Asterisk threading.lock, asterisk this is a lock object that's used to synchronize access to the shared accounts dictionary. It ensures that only one thread can access and modify the account balances at a time, preventing race conditions. Asterisk transfer underscore money, function asterisk. Asterisk with lock asterisk this is a context manager. It automatically acquires the lock at the beginning of the with block and releases the lock at the end of the block, even if an exception occurs. This ensures mutual exclusion. Asterisk balance check asterisk checks if the from underscore account has enough money. Asterisk debit and credit asterisk subtracts from the from underscore account and adds to the to underscore account. Asterisk time.sleep, Asterisk introduced to simulate processing time and increase the likelihood of a race condition if the lock wasn't used. Asterisk main function asterisk sets up the initial balances and calls the transfer_money function. Important notes about the Python example asterisk. Asterisk simplified asterisk this is a hugely simplified example. Real database systems have much more sophisticated transaction management features. Asterisk no rollback asterisk this example doesn't implement rollback in the event of an error during the transfer, example if crediting fails for some reason. In a real system, you would need to catch exceptions and undo the debit if the credit failed. The lock ensures that the debits and credits don't interleave with other transactions, but doesn't by itself guarantee atomicity in the face of errors. Asterisk in-memory asterisk this code uses an in-memory dictionary. The data is not persistent. Asterisk concurrency asterisk the threading.lock provides basic concurrency control. However, it doesn't handle more complex concurrency scenarios like deadlocks. 7. Exam tips for OCRA level h446, slr10/1/3. Asterisk master the ACID properties asterisk know them inside and out. Be able to explain them with examples. Asterisk concurrency control asterisk understand locking, deadlocks, and two-phase locking, 2PL. Be able to describe how they work and why they are needed. Asterisk database logs asterisk be able to explain the purpose of database logs, what they contain, and how they are used for rollback and recovery. Asterisk transaction processing in context asterisk think about real-world examples of transaction processing systems, example banking, e-commerce, airline reservations. Asterisk code examples asterisk be able to write basic code snippets, like the Python example above, to illustrate transaction concepts. You may not be asked to write a complete transaction processing system, but being able to write simple code will demonstrate understanding. Asterisk potential exam questions asterisk. Asterisk explain the ACID properties and why they are important for transaction processing. Asterisk describe how locking can be used to ensure concurrency control in a database system. Asterisk what is a deadlock, and how can it be prevented or resolved? Asterisk explain the purpose of a database log, journal, and how it is used for recovery after a system crash. Asterisk describe the two phases of the two-phase locking protocol, 2PL. Asterisk discuss the differences between optimistic and pessimistic concurrency control. Asterisk revise related topics asterisk make sure you understand basic database concepts, SQL, especially begin transaction, commit, rollback, and concurrency. Asterisk past papers asterisk practice with past papers and mark schemes to familiarize yourself with the types of questions asked and the level of detail expected. 8. Further study. Asterisk database systems textbooks asterisk look for introductory database textbooks. They will have chapters on transaction processing. Asterisk online resources asterisk websites like Geeks for Geeks, Tutorials Point, and the documentation for database systems, example PostgreSQL, MySQL, have good explanations of transaction processing concepts. Asterisk OCR specification asterisk keep referring to the OCRA level computer science specification to make sure you are covering all the required topics. By studying these concepts, practicing with code, and reviewing past papers, you'll be well prepared for the transaction processing questions in your OCRA level computer science exam. Good luck.